Algebra A1, this is Unit 6. Lesson 6, we are talking about solving multi-step equations to determine if there is one solution like we've been getting, or in this case, no solution or infinity solutions. Now, no solution means that something would be a false statement, and infinite means it would be a true statement. So let's solve the first one to see what D actually equals. I have parentheses, so I'm going to do the distributive property. I'm going to get 15 times 20, which is 300. 15 times D, which is 15D, equals 420. I'm going to subtract 300 from both sides and get 15D equals 120. I'll divide by 15. I get D equals 8. So I get one solution. Only one check would be necessary in order to plug in 8 here to see if the one side equals 420. So what type of solution we got? Just one. Now for the next one, we're going to do the distributive property on both sides of the equation. I'm going to get 8 times 4 is 32 minus 16x equals 12 minus 20x. And don't do anything with the 4x. It's not inside the parenthesis. Let me fix this for you. Now we're going to combine like terms on either side, but looks like we have nothing common on the left side, but we do have something common on the right. Negative 20x plus 4x is negative 16x. I will solve for x by bringing the x's over to one side, and you're going to notice something brand new happening. The x's cancel out completely, and it says 32 equals 12, which means it's a false statement. That does not equal each other. And since they do not equal, we are going to say that it has no solution. Now, there are two symbols that represent no solution in math. It's a circle with a slash through it, or just what we've been doing, an empty set with no numbers inside it. So let me show you an example of each kind. In this, we're going to look at the x's going to one side, and that's kind of why I made sure that you brought the variables over first. It makes it a lot easier. Having a little problem with my pen here. There we go. And I get 3x plus 3 equals 9. Subtract the 3. I'm getting 3x equals 6, and one solution is given. That's why I made you graph on a line, because then you know there is one answer out of the entire number set that actually satisfies that equation to be equal to each other. Now in the next one, when I subtract the 5x's, we end up getting no x's left over, and 3 equaling 9 is a false statement. There is nothing to graph because there's no solution. Nothing with 5 times x plus 3 and 5x plus 9 will equal each other. It doesn't even make sense because these expressions are not the same. So either symbol with the circle with the slash through it, or the empty set. And then another scenario that can happen when we do solve for x, but there are none, and your statement comes out to be true for this equation. Since this is true, we're going to have a million answers, an infinity number of answers. because I don't know what number I can put in there because there's so many. Now, what we call that is all real numbers. We've used that symbol before. So there's 3 different scenarios here. Again, making sure that we understand what's what. But if the variable does not cancel out and it's still in the equation, you get 1. But when the variables basically disappear, a false statement gives us no solution, and a true statement gives me an infinite number. I can plug in any number I want. These expressions are always the same. And just look at them. 5x plus 3 does equal 5x plus 3. All right, at this point, you can see if you feel pretty comfortable trying these on your own. You could stop the video and try them, and then come back and check your work. Here are the answers. I get 4x when I combine like terms on the left side. Plus 2 equals 4x plus 2. Now, I'm looking at this now, and I notice those expressions are identical. So when they're identical, any number is going to be the solution to this because they are true statements. 4x plus 2 does equal 4x plus 2 for any value of x. If they ask you what kind of numbers, they're called all real numbers. That was in our number chart we talked about in the beginning of the school year. The next one you should have gotten, negative 2x minus 2 equals negative 2x plus 5. And right here I can see that the 2 expressions are not equal, but we're going to double check to make sure that the x's do cancel out. Negative 2 equals 5 is a false statement, so therefore no solution. And you can write the symbol. One of them's fine. I'm just showing you both. Don't know what they're going to use on the regions, so I show you both of them. The next one came out to be 10x plus 1 when we combine like terms on the one side. You do not need to swing anything over yet. And then when I distributed by 2, these expressions don't look the same either. 10x plus 1 equals 10x plus 2. So I'm going to subtract 10x to make sure this looks okay. And 1 equals 2 is a false statement. So therefore, no solution. And those are the symbols that represent that. Look at that carefully so that you can see that you actually should get no answer. Nothing for x in this will ever balance this equation out. Let's see what happens here. When I distributed, these expressions look exactly the same. It is a true statement that 6 does equal 6. Therefore, there's an infinite number of solutions. And you can say all real numbers will work in this equation. So not one solution, several, all of them that we know of. And then for this one, I wanted to see if you could find the infinite solutions, and the infinite ones are the ones that look identical to each other when you solve them or simplify them. So here, if I distribute this one, it may not look the same to you, but if you look at it carefully, you still have a positive 4k and a negative 32 on both sides. This is an example of an infinite solution. 9 minus 7x and 9 minus 7x is an infinite solution. They are true statements. And again, if you need to solve them, you could certainly go a step further just to see if the constants equal each other when the variables disappear. So you could do that, or you can start seeing that there's a connection between seeing if the expressions that we learned way back in the beginning of the year are the same. This one is not. 15 and 12 with the 2x is not going to be an infinite solution. So you can try a couple of these and come back and check them, and I'll tell you which one the answers are. This is another one that's an infinite solution. This one is not, because the x and the 2x are not the same. You could get one or none for the solution. I don't know right offhand without checking it. And all I'm asked to do is find out if they're equivalent, because I want an infinite solution. These expressions are not the same, so that will not be. This will not be. They're not equivalent. And yes, that will be an infinite solution because they're identical solutions. So write one thing you learned today about one, no, and infinite solutions. You can write all kinds of different things. When you have a variable that cancels out, if the constants are equal to each other or a true statement, they would have an infinite number of solutions like we just did in the last activity. The other thing is, if the variables cancel out and the constants are not equal, they will have absolutely no solution, and therefore you can use the symbol of the empty set. And obviously, if the variables do not cancel out or disappear, you would solve it and get one of your solutions. So you could have written any of those scenarios to represent that to help you out. If you need anything more re-explained, go back and rewatch those particular problems.